First of all, take us through digital twins. What are they? Where are they seeing use? Where's their value? Take us through.
Welcome. Good afternoon. Good morning. What are the digital twins? Well, as they are named, it's a virtual copy of our real world. It's more or less like a metaverse, but much more useful and applicable. And you can run with it experiments, be it on the future solution that you want to build or potential risk that you might have without it occurring in the real world and without the need of significant investment in it. It can be a copy of a company or a process of that company, a whole country, or a particular system like energy system. And currently they are being used indeed by almost all the industries. It has been started by energy industry, with energy industry and aerospace industries, but now most of the industries where there is a pressure on margin and there is a need to take complex decisions would use these digital twins. The value is particularly for the advanced digital twins is where you can experiment with future unprecedented scenarios. And you can add assets, add investments, change your business models, and run the future simulation and see what really works. You can also go beyond imagination. In particular, if the digital twins are integrated with AI, it can allow us, human beings, to see beyond our still very large but unprecedented way of looking into the future is allowed by these digital twins. And then they help us manage very complex systems. We can zoom in and out, zoom in to see the details of how a system machine works, zoom out to look at how it is integrated. And then the advanced digital twins allow us to zoom in and out through future. And one of such advanced digital twins is Swiss AI, the platform that is the platform of my company, Swiss AI. And our customers can see with that platform what could happen and design the future with modeling, simulation, and optimization. So you will see now a movie where you can see the physical models of machines. These are vehicles in this case that move through the system, and they move through the built environment, through real environment. And that simulation includes also modeling of each single person in across 1.6 billion people in the world. So we see them and their activities both now and in the future in the resolution of sub-second. And this allows our customers to look at detailed customer segments, in this case future battery electric vehicle drivers, to optimize their local strategy and operations. And they can do it for different scenarios: internal scenarios, business model changes, customer incentives, asset deployment, or external scenarios like change regulatory scenarios, regulations, changed economic situation, changed people behavior. So that allows the customers to choose their best pathway for business.
Okay, so I mentioned in the intro a few of the sectors that you're active in. Give us an example of one of those sectors and what you're doing there, more specifically, more concretely.
So, for example, the mobility. Some of our customers, like Mercedes, use the simulation to stay profitable while transitioning from fossil fuels to electric. And there's a lot of complex questions to be asked and decisions to be made: where to put these chargers, when to roll them out, what technology to put where. If you remember the film, imagine you play that into the future. And you have different battery technology in cars. They roll out differently across geographies. You have different behavior of the drivers. And then you have different behavior of competition. And all of that has to translate in a local optima. But at the same time, we have a global optima. So how do you optimize the two at the same time? Stay profitable while maintaining large quality of service across a whole continent. There are millions of goods transported every day, and if we increase the precision of that delivery, for example, by 5%, what impact would that have? So this is some of the questions that our customers run on the system. We also look at energy system. So our energy system is a great example because it's very, very complex. And that's a good example of application of digital twins. So say a Nord Stream blows up, you can use a digital twin like Swiss AI's to see what impact would that have on your particular business. Another example is, again, on energy space, is a longer-term impact and scenario where you have the next 20 years, you want to know what amounts of energy provision you have to install where within the system, and how do you integrate it with dynamic supply, with ancillary systems, with batteries, with new technologies coming in. And that is the future demand. And maybe the last quick example is COVID. We modeled the COVID for the Swiss authorities, and that was when in Switzerland there was only 20 cases. We modeled the first peak. We had a 10% error on distribution of ICU units and the fatalities across all hospitals within Switzerland. And we had 5% error on understanding how the roads of the highway system would change their usage. So this is some examples.
So enormous potential. It's a very exciting technology. There must be some challenges, though.
Yes, the main challenge is us, the human beings. It's typical when we deal with a big machine. We are potentially not exactly ready. Both as humans, we are just learning to put prompts into ChatGPT. And here we are dealing with so much more potential, so many more scales. And we don't yet trust these systems. And our organizations are also not quite ready. There are some smart pioneers that understand the value and potential of these technologies. And these will lead us into the future so that we can apply it into the businesses at a greater scale where the real potential lies. And I'm indeed super excited about these tools and their applications. They're very, very powerful tools to take decisions. And in particular, in spaces where we really need transition, like, for example, sustainability, they are critical. So our customers would use Swiss AI to run their decarbonization pathways. But they wouldn't run one pathway. They would run 60,000 pathways so that these potentials can be really most profitable possible while reaching the sustainability targets. And the other exciting thing is that this technology is not island solution, but it's an integrated, dynamic, learning, responsive system. And that is really exciting.
Fantastic, Anna. Well, thank you very much, and thank you for taking us through that in the first instance. Let's look at this now in a more applied sense. I'm very pleased to be able to introduce Sebastiaan Nobs, who's the Head of Business Development at Corporate Partnerships here at Swiss Re Corporate Solutions. Sebastiaan, welcome to the event. We've heard from Anna how digital twins are applied across a wide range of industries and the opportunities they present. Sounds fantastically exciting. How are we applying it here in the insurance industry?
Yeah, thank you, Anthony. I think if you look at the insurance industry, I see three angles, basically. You have the reduction of cost, you have the increase in accuracy of risk assessment, and then the fraud detection. So let's look at 4 examples of opportunities. You have the risk assessment and pricing. So if you imagine a digital twin of a building showing the effects of fire and flood, for instance, that helps you then to get a more accurate pricing of your policies. The second one is the preventive measures, so predictive maintenance and looking at potential failure points and acting before they happen. That is also one of the key elements. Then we have the claims management, So if you take the simulation of a car accident in the digital twin, you can assess the damage of the car, and you can also be more precise in your reparations of the car. And then ultimately, in the reduction of fraud, you can compare a claim with the digital twin data that you have, and then you can identify whether the car was really at the place that the owner believes it was. So.
Fantastic. And then, so the same question for you on the challenges. What are the challenges for insurers on this?
Yeah, I think I see 5 key challenges. Obviously, there are others, but the first one is data privacy and security. So digital twins require a lot of detailed and sensitive data. And there, you need to make sure as an insurer, but also other players in the digital twin space, that your data is complying with data protection, with regulations. And if you don't, that can really impact your reputation quite quickly. The second point is on accuracy. Data is always as good as the quality of the data that you have. So if you create a digital twin based on erroneous data or incomplete data, and you make decisions based on that, that can lead to quite some problems downstream. Then we have the technological complexity, because running a digital twin is something that is technically quite complex, and then you need also the expertise of it. And that's not really in our expertise necessarily, the systems and the technology. So there you have to make sure that either you have the proper skills in the company, or you can work with a vendor, but then you have a dependency on a vendor, and that creates some other problems if they're not able to keep up with the technology, or even they don't provide the expected support when it's required. And the final one, I would say, is the ethical concerns, because with a digital twin, for instance, in the health insurance space, the more accurate you become about the individual's health, the more it can lead potentially to discrimination or unfair treatment.
Okay. All right. And then we're using digital twins here at Swiss Re. Just briefly give us a quick insight into...
Yes, we are. So we've developed our RDS platform, which stands for Risk, Data and Services. And we have 3 key pillars. So the first pillar is property exposure. And that simulates the potential disruptions on assets. So the risk managers can really have a better decision on the portfolio and understand better the exposure of their assets. The second one is the sustainability compass, and there we help risk managers to take control of the climate-related risk, and we can also help them to input into the TCFD reporting requirements. And ultimately, on the supply chain resilience, we help companies better understand potential disruptions on their own supply chain. We have one example, which is the company Holcim, for which we simulated climate-related scenarios on their 62 properties, 62 sites, and we managed to look at potential disruptions up to the year 2085, so running simulations. That was quite good. We're going to look now, I think, at the video, which is not from Holcim, but it's just a demo of the tool. And I have to say, Anthony, one thing is when you sit with a client and you've plotted already some of their sites and the locations into the tool, and you show them what is the potential impact of a flood or a fire or any kind of risk that could happen, I think that's really an eye-opener, because usually they sit on a lot of data, but they don't have the visualization of what it means. Right. And that really hits the ball in the park.
Really brings it home. And I think, if I remember correctly, on CatNet, about 2 years ago, we ran the scenarios on the floods in southern Germany, and that reached about a 90% accuracy ratio. Actually very similar to what you were saying, Anna, as well. Well, Sebastiaan, thank you very much indeed for that. And finally, I'm very pleased to be able to introduce Dr. Anja Vischer, who is the Senior Emerging Risk Manager at the Swiss Re Institute, who is one of the report authors and also one of the editors. Anja, thank you so much for joining us today. We've talked a lot about opportunities and benefits. It's been quite a rosy sort of picture that we've painted so far. Take us into the risks. This is what we're really about.
Sure, thanks, Anthony. So as we've heard, there's so many benefits of these digital twins that they can bring to cost optimization, process optimization, and so on. But as with any emerging technology, there are emerging risks, right? And it's very good that we're aware of these risks and that we have such open dialogues as we do today, so that we can be aware of what can go wrong and mitigate it on time, right? So For today, let us talk perhaps about three major risks that might be worth mentioning. So first, we have to remember that these digital twins, they're basically models of the real world, right? They're replicas. And as such, they can never be perfect copies of the object or the process or the force that they're modeling. There's always some kind of assumption or simplification that we introduce in the models, right? This is just the inherent nature of all models. So we have to be aware of the resolution of the digital twin that we're using and the limits on this resolution. So to offer you, for example, a practical example, you talked a lot about digital twins of processes. We also have digital twins of physical objects. So for example, think of a digital twin of a car and manufacturing companies that use these digital twins for safety product testing, for example, of these cars. These digital twins of cars, they're very complex, but they're modeled down to the resolution of the material used in each part. But during the manufacturing process, there's many imperfections that are being introduced into these parts. These imperfections are random, and they cannot be modeled. They oftentimes cannot even be observed without actually breaking the part up and seeing what is the imperfection inside. It is also, in terms of these physical digital twins of physical objects, it is very difficult to model aging of materials, for example, or chemical degradation, because they really depend on the environment around. And so if we have multiple manufacturers maybe relying on similar digital twins, where there are issues that might be overlooked in terms of these very precise resolution-based errors, we could end up with some kind of systemic risk being introduced into certain products, right? So it's very important that when we're using digital twins, that we ask the right questions that can be answered with the resolution of this digital twin, right? So the art of using the digital twin is the art of asking the right question that's suited for the resolution. Secondly, we need to consider also the fact that we're not only modeling the real world in these digital twins, but the digital twins are increasingly going to start influencing our real world. And Anna has talked a lot about these advanced digital twins. So increasingly, they will be used to, in real time, operate and control dynamically either objects or processes. So you can think of large engines being controlled by digital twins, but also traffic lights in a city. Self-driving cars are also being driven by digital twins. And oftentimes, the digital twin has to, in real time, make some decision-making to optimize the control of this object or process, right? And this decision-making is oftentimes being done using machine learning algorithms that are very complex. They are way more complex than our human mind can understand. And there's a lack of transparency. Basically, they're a black box, and we do not know what inputs they're basing their decisions on. So, though they're much better than us at optimizing processes and so on, they could introduce errors without the human user even being aware that errors are being introduced, right? Because that is how much there's lack of transparency, right? So again, we really need to think of these digital twins as something that can really benefit our systems, but that there are these errors that can be introduced, and we really need to work on the transparency of these digital twins' decision-making that can then feed back into the human user loop, right? And finally, it is precisely because these digital twins are increasingly influencing our real world that cyber risk is very important, right? So these digital twins, they enable collaborations across teams and companies, and many different users can work together on digital platforms to design a digital twin. But then there's also the risk of hacks into these digital platforms. There's risk of private and confidential data being stolen. There's also risk of IP theft. For example, if you have models of these digital twins that can be stolen. But because the digital twins are also affecting the real world, there's also the risk that hackers can gain control of physical objects or processes, and that can lead to uncontrollable behaviors, right? So in this sense, the businesses really need to be sure that digital twins are secure and privacy conscious. And again, it boils down to asking the right questions so that we can focus our digital twins, and we can really limit the amount of private data and confidential data that is needed for the digital twin, and that we can limit the amount of users that need access to different levels of the digital twins. Yeah.
Fantastic, Anja. Well, thank you very much indeed. And I think there's obviously more on this in the Sonar report itself, if you'd like to read more. So thank you very much indeed, Anja. So just a last sort of quick fire round for the speakers. And Anja, I think we'll start with you on this. What is the future for digital twins then? What's exciting you? Any other sort of observations on the future for digital twins?
Despite me being negative a bit earlier, the future is very exciting, right? The digital twins will bring many benefits. They will become more precise, they will become more prevalent, and they will increasingly influence the real world around us, right, as we discussed. They will also become cheaper, so they will be increasingly used by smaller companies, and they will also be easier to use, right? So this is all good for insurers because they will limit the risk and they will help us preempt the risk before it occurs and mitigate it or reduce it. Just one issue that I foresee is that it might introduce systemic risk into the system. Mm-hmm. And we also have to be careful the digital twins don't make the world too perfect, because a perfect world is less diverse, and diversity is key for resilience.
Thank you, Anja.
Yeah.
Risk management to the core there.
Exactly.
Very good. Sebastiaan?
Yeah, I think also a very optimistic view of the future. I think everything seems to be accelerating, and I think we're really at a turning point in terms of technology. If you just think about AR, VR, AI, quantum computing, IoT, blockchain, 5G, 6G, metaverse, all these capabilities will help, power the digital twins of tomorrow. And I believe that we're going to see a lot of developments happening in that space, but we always have to keep an eye on the risks.
Very good. Emerging technologies equals emerging risks, Sebastiaan. Yeah, very good. Anna?
I am also quite hopeful. For me, the advanced digital twins allow us to interact better with the machine and AI, so we can get better insights about our world, better steer and manage our world, create opportunity and manage the risk. But it also makes it possible to solve the problems which were previously unsolvable. And perhaps the most exciting thing for me is that our learning capability. So once we really accelerate the answers that the digital twin provides us, so we accelerate the amount of options and we speed up the time, that allows us to learn in an accelerated fashion from the machines so that we can take the better decisions for our businesses.
All right, brilliant. Well, thank you, all three of you. Thank you very much indeed for that. Let's go to questions now. And I think we'll first take questions in the room if we have any. There is a roving mic. Are there any questions from the floor?
Thank you. My name is Rolf Tanner. I'm from Swiss Re. And when I started listening to this presentation and you started out with digital twins, Anna, I initially thought, oh, I'm going to understand about 2% of what she's saying, maybe 3%. But the further we progressed in the discussion, it dawned a bit upon me that this is a model. What are you talking about? This is a model. And I was wondering, why do you call it digital twin? Because it seems to me it's just a glorified form of models. And I mean, why do we call it now digital twin? Is it a marketing gag, or is there really a qualitative difference between, say, the conventional model as we know it from risk management and the digital twin?
Thank you for this question. Digital twin of a society or the world is a complex thing. It took us, I believe, 13 years to build this. So, typical digital twin can be simple, can be a machine and a digital twin of machine. But what I call advanced digital twins is when you have these multiple models, indeed, but then you can have an interaction in between them, like the real world, And you can project, let's say, distribution of risk or distribution of certain occurrence of certain events within different levels, and they interact. That's one. Second thing is that they learn. And this is the AI. Maybe that's beyond digital twin, the typically called digital twin. So in our system, for example, the individuals, which we call agents, which could be machines or like self-driving cars or people, they learn from their experience, and then they will take different decisions. So we can project distributed decision-making within the system, which has never occurred. And to project that distributed decision or, let's say, rollout of technology within the society, you need to have many, many, many layers of models, data, algorithms, which are integrated. So it's not just one model. It's potentially more complex, but depending, the word digital twin has been used for so many applications. It's not just one thing, so you cannot nail it down to one particular application.
The gentleman there.
My name is Hans-Jürgen Maurers from the Swiss Sonntagszeitung and the German radio station Deutschlandfunk. When I saw this chart about San Francisco, and you were describing to us all the data you will collect in the future, it seems to me we're approaching, or you're trying to implement another huge step in surveillance capitalism, which leads to the next question automatically. Are you going to produce the death of privacy? Second question, I'm thankful that you mentioned the artificial intelligence issue, which is, of course, a really big one. Everybody knows that. You know that some of the creators have warned and asked for a moratorium. Are you going to do a moratorium on your AI projects? Plus, the next issue that's coming out of that is, you said there's a Swiss professor who says we shouldn't talk about artificial intelligence. We should talk about what's really happening, which is machine learning. Might be a little different, but anyway. So if you rely more and more on machine learning, and you said, and I'm grateful for that it's might be so much, even more than we can understand, then you're obviously crossing a threshold, which reminds me a bit, you're jumping down a cliff, but you don't know if there's water at the bottom or a rock or some crocodiles or whatever waiting. So I wonder why we would do that to get dependent on machines. And if I may add another one, because it's in the report about the hacking. Every day, companies, universities, hospitals, governments are hacked. It's happening every day. Damage worldwide, $5 trillion. With the total digitalization, you open more routes for hackers. With AI, you will even introduce more routes for the hackers who will use AI. And then you said, quite rightly, they might attack with AI, for instance, critical infrastructure. So how are you going to handle that? Thank you.
Okay, series of questions. Anna, first, I think, is the privacy piece. Why don't you?
Surveillance, wow. Our digital twin is fully GDPR compliant, and I'm proud to say that we don't track a single person in it. We have a correctness, a very, very correct distribution on the behavior, which was illustrated by COVID case, but we do it without tracking people, which is quite unusual. Most of the companies have tracked people in order to arrive to that level of precision. We didn't, because we actually started from the ethics and on what we apply the digital twins. So we apply them on the future pathway where we can help the humanity. So one of the applications is sustainability, decarbonization, electromobility, renewable energy, real estate, retail, things which are generally to support the humanity. So I think that it's important with every tool, especially such a powerful tool that we are here talking about, that it's applied correctly by the people who use it. And for now, we are able to do that, and we are able to steer it. And you also mentioned, you asked about the inherent direction and ethics. Well, that's a part of our policies, and that's a part of, I believe, Swissness of what we do.
Very good. And there was a question in there as well on the taxonomy, machine learning, artificial intelligence.
Yes, indeed. There are two different types of machine learning or artificial intelligence. That's, again, one of these things which is being used and mixed in different expressions. One is physical models, and one is not physical models. So for physical models, we are actually able to track the reasons. They are physically modeled. So the electron flies very quickly from here to Paris, and it's physically possible to calculate. So that's a physical model. Of course, the moment you go deeper, you start to get some elements of the solution where you have to potentially research why the system came up with that solution. And there are some research direction, in fact, right now, which is going right into that space. Did I answer the question?
Yes, I feel so. Do you?
No. Don't want to be rude.
We'll come back, if we may, on that. There were several other questions in the room. Could we just see hands? The lady there. Thank you.
Thank you very much for all presentations. Today, it's the first time I heard about digital twins, and actually I like the term. It's quite easy to remember. Very user-friendly, and I believe in science there are more complicated terms that people end up just using abbreviations and then thinking, what does it mean? So the question is about the model, actually the model that you use. I understand you use data to treat, to get some parameters for simulations. So do you also allow to incorporate in your models expert judgments, or you just rely on historical data? Thank you.
Anja.
This was a question for Anna's. Wait, was it a question for Anna's?
Okay.
Oh, I can.
Yeah, Anja, please.
So this was about these advanced digital twins that are operating the machines, or? You know better. I think it's very important to, as I was saying, that especially as machine learning becomes more and more prevalent in these digital twins and in the way that they dynamically operate the machines, that we work on increasing the transparency of the decisions of this machine learning, right? So I can use an example to illustrate. For example, if you have a self-driving car that is being self-driven by some digital twin. Back in the 90s, you would have some kind of speedometer, and you would say, I want the speed between 50 to 60 kilometers per hour, and the speedometer would kind of take the decisions based on the inputs that a human user has given him, right? And he would increase the speed if it's going too slow, or decrease if it's going too fast. Now with the digital twins, and what we were saying about the machine learning, is that the digital twin is deciding itself based on the environment, how to make the decisions, right? So it could be that the self-driving car slows down, even though it's below the speed limit, because it knows that something is going to happen in the future, like there's a curve coming ahead, or there's a traffic accident ahead. And this is where you said expert users and stuff. This is where the user who's using the machine is not aware of why the machine learning is making this decision, right? And increasing the transparency in why certain optimization decisions were made by the machine learning would improve the usability of these machine learning systems. So if the car would say, I'm now slowing down because there's a curve ahead, this would kind of optimize this relationship between a human user and a machine learning operated machine, right? So I don't know what is the case on each digital twin example, but it is definitely that going forward, we need to improve this connection between humans and machines and allow for both to be in the control of, no, more for humans actually. We need to stop losing control of the decision making and kind of use machine learning and these digital twins as more of a augmented intelligence rather than artificial intelligence, right? Something that's augmenting our decision making. Yeah. Does that answer the question?
Well, I understand we're having some problems with asking questions online, for which I apologise. We'll try and deal with that. We do have a couple of questions more in the room.
Hi, James Norman from PwC. I think when the best map functions first came up on our phones, right? Very people were skeptical. Okay, is that the best route or not? And people started to question, But after, I know at least myself, when I'm going to the main station, Hauptbahnhof, I just look at it, I follow exactly what it says, right? I kind of wonder, when these models are getting more and more difficult to understand, you talk about them being, beyond the scope of our brain to kind of comprehend exactly how the neural network's working. I'd be interested is how you maintain the staff, right, and how they can continue to keep validating these models, keep understanding how to make sure these models, these essentially decisions it's making are actually doing what it should be doing, right? Because you said if you start using for real world situations, at some point you might have realized, okay, it didn't do the right thing. At that point, it's too late. So I kind of wonder how you think about how you keep your people interested enough to say, I'm going to keep looking at this model, keep challenging this model, when after a while they start to say, well, it's behaved itself the last 2 years, it's going to behave itself in the future. So I could be interested in your viewpoints around how you continue to validate the models and also motivate the people to keep looking at these models to make sure it's not going to do something crazy in the future.
Anna.
Yes, we have about 50 plus papers out of ETH, which was many PhDs and other senior staff which wrote these models and components of the system. So there was a validation before we even started. And now customers ask for their own validations. They want to see, like Kajima Corporation, which is one of the largest construction companies in Japan, wants to see how do we foresee who is coming to the skyscrapers at which time, or who is using a certain large who, not exactly who, but what kind of people at which time would come for which purpose into a certain area. And we need to calibrate and validate that locally. Now, so the validation and calibration is an ongoing effort, and it's going to remain an ongoing effort. In terms of how do we motivate people, when you have a technology which is really on the forefront of the technological advancement worldwide, which is the case here, you don't need to organize seminars. The seminars happen over every lunch. And it's just exciting for these people to be a part of creation of it. So, and we also are motivated by what we do. So the type of application, we want to lower the risk, improve profitability of sectors that we really want to help advancing. So the people who are participating in it are also ethically aligned with the purpose. I think that's it.
Thank you, Anna. Now, Sebastian,
Can I just add something to that? Because I think it's really important to understand what your models are doing, right? And I think there was an interview from Max Tegmark, who is an MIT professor, and he said the risk that you have is that the moment you don't understand what your model is doing, that's where you get really into trouble. And he was giving the example of the Boeing 737 MAX that crashed a few times, and a lot of people died because of that, and it was because they didn't understand the model anymore. And they just thought, okay, we trust because, as you said before, it has behaved well in the past, right? So let's, and I don't think we can play with that. So we have to be extremely careful that we still understand what we're doing.
Well, maybe on the model of the Boeing, basically the important is that to keep the knowledge. So you don't aggregate the knowledge and pass it on to the model and then forget. So you have to keep that knowledge. In the case of Boeing, they actually did not. They passed it on into the model, and then they didn't anymore remember why the model is taking certain decisions. So it's important that you keep the key knowledge within within the development team, possibly.
Thank you. Thank you. Then, Sebastiaan, I feel duty-bound that we've talked a lot about the property and casualty side of our business. We haven't talked about life and health at all. Obviously, huge applications from a life and health perspective. Can you very quickly, in our last minute or so, just tell us about the life and health side?
I think, well, obviously you can start with hospitals, right? So that's the easy one, the digital twin of a hospital and you know, the different procedures if you have to lock down and stuff like that. But obviously there are other applications like, for instance, patient-specific care that you can, you know, if you have it in the digital twin, you can start simulating how things will happen, how the body is going to react to certain elements. You have drug development also that you can test with the digital twin. And then obviously the training and education, which is quite important. So if you can simulate already an operations on a patient's digital twin before you're actually going to start operating for real, I think that can help you avoid certain risks.
Fantastic, Sebastiaan. Well, thank you very much to you, and thank you to all of our speakers, obviously Dr. Anja Gawlikowska, Sebastiaan Nobs and Dr. Anja Vischer. Thank you very much indeed, and also to the Sonar team for producing the report. If you'd like to read more on Sonar, you can do so obviously on the website, swissre.com. There's a dedicated Sonar page there. And thank you very much indeed for tuning in, and we look forward to welcoming you next year, if not before. Thank you.